Ham class, we continue Unit 8 with translations of quadratic functions. So if you could think back to all the transformations you learned last school year, there's translation means a slide. So it's not like a rotation where the function or the line will turn, but it just slides, meaning it's going to shift right, it's going to shift left, it'll shift up, or it'll shift down. Okay, so it's a slide across the coordinate plane. So let's start off with a parent function is the most basic function of a certain type, while the linear parent function is f of x will equal x, like the function of x equals x. The quadratic parent function is f of x equals x squared. Complete a to b to see how changes to the parent function will change the function's graph as well. Complete the table for f of x and graph the parent function. Then repeat the steps for g of x and h of x using the same graph. Okay, so if we plug in the value -2 for x, we can go -2 raised to the second power. What will f of x equal, or what will y equal? Y should then equal 4. Okay, and same thing here. If we plug in a 1 for x, then y will equal 1. Sorry, I meant to plug in -1. My fault. -1 times -1 will equal +1. Okay, if we plug in a 0 and square that, we're going to get 0. If we plug in a 1 and square that, we're going to get 1. We plug in a 2 and square that, we're going to get 4, and so on. Let me go ahead and highlight these. Okay, let's try again. So let's plug in a -2 into this function, and we have -2 squared plus 2 is going to equal 6. Okay, I'll go ahead and just write the numbers to be a little faster here. Okay, we plug in these values, we're going to get a 6, a 3, a 2, a 3, and a 6. And lastly, we plug in these values into the third function. And let me just write the values out. I solved it a few minutes ago. I checked it a few minutes ago. Hold on, let me verify one thing. Okay, this is supposed to be 1 minus 9. Okay, and let me highlight these y values. All right, and right now we can go ahead and graph these. I graphed them earlier, but if we have -2 for x, then we have 4 for y. Okay, that would be right up here. If we have -1 and a +1, that's going to be our dot right here. 0, 0, we're going to have a dot on the origin, of course. And for this function, if we have 1 for x, we have 1 for y. That lands us right here. And for this function, if we have 2 for x, we have 4 for y, okay, which lands us right here. So my parabolas aren't perfect, but you could see the general trend, right? So we got 3 once we graph all three functions, we have three functions that all open upwards. They all have minimums, and they all fall on the same axis. They all have an axis of symmetry which equals 0. So x equals 0 for the axis of symmetry for all three of these. So describe how the equation and the graph of g of x compares to f of x. So f of x is here running through the origin, g of x is up here. We can say that g of x is graphed 2 units or 2 spaces up from f of x. Okay, you notice how we added 2? We added 2, so that means that we had a vertical shift of 2 up, 2 spaces up. And now describe how the equation and the graph of h of x compares to f of x. We could say that h of x is graphed 9 spaces, 9 spaces, or I should say units, nine units down from f of x. Okay. If f of x equals x squared, then f of x plus d shifts the parabola vertically. That's what we just saw over here, okay? We have the parent function plus another number, so it shifts the parabola vertically. If that number d, okay, looking at this right here, the constant, if the number d is greater than 0, then f of x plus d, if it's a plus, will shift the parabola up. And now, if d is greater than 0 again, and f of x minus d, if we have f of x minus d instead, that's going to shift the parabola in the opposite direction. It's going to shift it downwards. So this will shift it down. And the proof of that is up here. Okay, when it's the parent function plus a number, that's going to shift it up. And then when we have the parent function minus a number, that's going to shift the parabola downwards. Lorenzo translated f of x to create m of x as shown. Use the graph to answer a and b. Write a function to represent m of x. So we could say that m of x equals f of x minus 7, because what we see here is a downward shift of 7 units. Okay, we go down 1, 2, 3, 4, 5, 6, 7. So it's f of x minus 7. Compare the features of m of x and f of x in the table, then circle the features of a graph that a vertical shift will change. And circle. Okay, I'll save that for later. So the vertex for the first one is 0, 0. The vertex for m of x is 0, negative 7. The domain is all real numbers. The range here, we should have y is greater than or equal to 0. And the range for the next function is y is greater than or equal to negative 7. The axis of symmetry, okay, what line passes through the middle of them? It's right there on the 0. So we're going to have x equals 0 for both of them. Okay, what's it asking here? Circle the features of a graph that a vertical shift will change. Okay, a vertical shift will change the vertex, yes, because the vertex here and the vertex here are different. Okay, and there was a vertical change, it changed the vertex. It won't change the domain, the x values are all the same for both of them. It will change the range though, yes, it changes the range. Okay, it didn't change the axis of symmetry though. No matter how far up or far down you go, that axis of symmetry stays the same. Okay. The parent function f of x equals x squared is shown at the right. In a through b, observe how transforming a function using f times the quantity x minus c affects the graph of f of x. Okay, so we got a different type of function here. So this is, I guess you could call it a different parent function. Different parent function here. It doesn't look like the one we saw on the previous side. Enter the function p of x equals the quantity x minus 2 squared into your calculator. So now's a great time to use the Desmos calculator so you can see the parabolas that it creates. Sketch its graph at the right and describe how the equation and the graph compare to f of x. Okay, so once we type this into the calculator, let's see what we get. Okay, it's going to move the vertex over 2 spaces. So I'm getting this only by typing it into the Desmos calculator. And I'm getting a parabola that is 2 spaces to the right. Okay. The graph shifts 2 spaces or units to the right. Predict how the graph of r of x equals the quantity x plus 4 squared would relate to f of x. Check your prediction using a graphing calculator and sketch the graph of r of x on the same grid above. So if you want to take a minute to type this into your Desmos calculator, that'd be a good move right there. Just get used to the functions, get used to how they would look. And I did this a little while ago, and what I found was the vertex was here, and this shifted our function over 4 spaces to the left. Okay, so this first one was called p of x, the first one we shifted, and the next one was called r of x. Let me highlight those. Okay, so if this first function where you have x minus a number, that shifted it to the right, and now all of a sudden we have x plus a number in parentheses, this is going to shift it to the opposite side, the left. Okay, so this is going to shift the parabola horizontally. And if c is greater than 0 and f times the quantity x minus c shifts the parabola right, then if we have the same situation where c is greater than 0, f times the quantity x plus c shifts the parabola left. And let's complete the table to compare the features of f of x and p of x above. Then circle the features that a horizontal shift will change. Okay, look at the vertex here. And the original function was at 0, 0. P of x was at 2, 0. Yep. The domain is the same for both of them. Whoops. All real numbers. And the range is the same. and the axis of symmetry is different. So the axis of symmetry for f of x was x equals 0, and the axis of symmetry for p of x is x equals 2. Okay, and which feature, a feature that a horizontal shift would change would be, it changes the vertex and it changes the axis of symmetry. Okay, down to the last few here. The graph of f of x equals x squared was transformed to create the functions a through d. Use the functions to answer 4 through 6. Describe each transformation in your own words. So what I would do right here is just graph these using your Desmos calculator, but sometimes we can look at these and just tell what it's going to do. So this one right here, if we flip back to the first page, okay, this is going to shift the parabola down, and it's going to shift it down by 2.5 spaces. Okay, so it's a vertical shift down by 2.5 units. And for B, this one looks like the parent function above. Let me look at it. So this is going to be a horizontal shift. And it's negative, so it's going to be 8 units to the right. 8 units right. This next one, for C, this is the opposite situation as B. So it's going to be a horizontal shift, but in the opposite direction. This is going to be a horizontal shift 2.5 units left. And for D, x squared minus 8, that looks like a vertical shift. Let's see here. Okay, yes, just like this one here, x squared minus 8. So that's going to be a shift downwards. So this one represents a vertical shift 8 units down. Okay, hopefully you can read that. Okay, my writing got a little bit small. Which cards have functions with the same axis of symmetry as f of x? So A and D. So this is where you, I wish I had a calculator to show you with Desmos, but I put them into the Desmos calculator, and what I found is that A and D have the same axis of symmetry, okay, and the same range as f of x, the same y values, B and C, and the same vertex. None of them had the same exact vertex, okay? But I did look up these answers. These are all correct. Okay, so I would really, really highly recommend just go onto your Desmos calculator, type in these functions, and then see how they relate. Okay, see where they are in relation to each other. And lastly, Haley graphed one of the functions below. Which function did Haley graph? Typing this in, I saw that it's the same exact function as B right here. This function equals this graph. All right, so the homework page is just more of the same. Let me bring that out right here. And then please ask me questions if you have them in class. And then if you need help with your Desmos calculator, let me know also. And we'll see you in class. Thank you.